Year 10. Here are the marked solutions for the topic test on the unit that you've just done, so transformation, similarity and congruence. We're going to mark them in the same way that we did with the previous topic test. So if you've got yours there, then mark it as I'm marking this one. It's the best way to do it. So you can pause the video and do your corrections as well if you need to. So starting with our first question. So a triangle has coordinates A, B and C, 0, 0, 0, 3, 5, 0, and it is enlarged by a scale factor of 2 centered at the origin. Always useful to draw a little diagram. You don't have to, but it's useful to see what it is that you're trying to do. So we need to write down the 3 coordinates of the enlarged triangle. Well, if it's enlarged by scale factor 2, then this will be twice as long, so that is out at 10. This will be twice as long, that's out at 6, and this one, because it's at the origin, doesn't move. So we're looking for the coordinates 0, 0, 0, 6 and 10, 0. In any order, it doesn't matter what order you've written them down in. 1 mark for each. Question 2 is an enlargement question. So we've got part A, enlargement scale factor of 1/2, part B, scale factor -2. So part A, enlarge the triangle by a scale factor 1/2 about 0.33. So find 0.33, and you're doing a scale factor of 1/2. So from the centre of enlargement to this point down here, it is 1, 2, 3, 4 to the left and 2 down. So 1/2 of that, 2 to the left and 1 down, will give you my corresponding corner. And I just draw my half size enlargement. So if you have got a triangle that is half the size, so it's the correct size, you get 1 mark for the correct size. And you get 1 mark for it being in the correct position. So if you've got that in exactly the right size and the right place, you get 2 marks. Part B, same idea behind the marking here. This time though we've got scale factor -2. This is basically what's on the higher level papers. You don't get negative enlargements on the foundation papers. So point -1, 1 is here. It's actually the corner of the triangle, and we are going to do scale factor -2. So how far to this point? 1, 2, 3, 4, 5, 6 to the left. So to its corresponding point, it will be -2 times 6. Actually, -2 times -6, which is 12. So 12 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That point there. And then similarly with this one. So again, if you've got a correct size, doesn't matter which way up it is, if you've got triangle R is twice as big, you get 1 mark. If you've got it in the correct position, you get the second mark. Use your rulers to check. Always a good idea to check that the position is correct with these. So you put your ruler on the centre of enlargement and line it up with the corresponding corners of a triangle. If they're all in line, then it's correct. So all of those are in line. You will see these sometimes drawn on diagrams with as ray lines. It just makes the diagram really cluttered and you can't see. So when examiners are marking, it's difficult for them to read it. So just use your ruler as a check. So and this still works as well with negatives. So there's your centre of enlargement, there's one corner, there's the other corner. Are they all in line? Yes. Are they all in line? Yes. Question 3, another negative enlargement. Same principle behind it. If you got it fully correct, you get both marks. If you've got the correct size, or you've got 2 of those corners in the right place, you get 1 mark. And again, we can check this using our ruler. So there's the tall pointy bit of that triangle, that's that one there. Are they in line? Yes. Are the right angled corners in line? Yes. And is the third one? Yes. So you know if you've got that the right size there, it's going to be in the correct position. Moving on to question 4, which moves on to congruent triangles. So what do we know about congruent triangles? We know that they are exactly the same size and shape. So we have 4 triangles here, we just need to double check them. Not an awful lot I can see about that one because I don't know any. Well, I do know that that angle and that angle are the same because I've got an isosceles triangle. So what's that? 48 and 48. This one, working that angle out, it's 49. This one, I've already got 2 angles again. I can work out the third angle is 44. And the last one, if I work out the third angle, it's 84. So clearly, that's not congruent to anything because I've got angles of 48. This isn't, so I've got this one and this one. I've got the same 3 angles. I just now need to compare corresponding sides. The best way to do this is to look at the angle opposite, the side opposite angle 49 is 6 centimeters, and 6.5 opposite 47. Opposite 49 is 6 centimeters, and opposite 47 it's 6.5. So we know we've got corresponding sides the same, and that's what we include in our reason. So first of all, we need to state that B and D are congruent triangles, and that's because they both have the same angles and 2 corresponding sides that are equal. So 1 mark for identifying B and D, but to get that 1 mark you must have got at least 2 of these triangles with the extra angles written in to show you working. Your final mark is for identifying one of the standard reasons for congruency. So they both have the same angles and 2 corresponding sides are equal. That should be written, but absolutely must be written, is that. Oops, I've got an extra mark in it now. Just worth 2 marks. Moving on to question 5. Similar triangles. Now I've got 3 variations of the solution for this, depending on how you do this. They're all correct. So first of all, because we've got similar triangles, what we've got are sides in the same ratio. So I can see that these 2 angles at the bottom, that side is corresponding to that, and that side is corresponding to that, and that one is corresponding to that. So this one looks at the ratio of the big triangle to the small triangle. X over 2.5 is equal to 12 over 3. That over that equal to 12 over 3. So if you've written that equation down, you get 1 mark. Working it out by multiplying by 2.5 both sides, and working that out gives you x is equal to 10. You could do it as the ratio within the triangle. So ratio of the sides in the big triangle is the same as ratio of the sides in the small triangle. So x over 12 is equal to 2.5 over 3. If you've written that down, that's it, your first mark. And you'll notice that when I multiply both sides by 12, I get exactly the same line there. So I know I'm going to get the same answer. The third version is to look at for a scale factor. So if I go from the small triangle to the large triangle, I'm timesing the 3 times by 4 to get 12 centimeters. So this triangle, the lengths are 4 times bigger than that triangle. So to get both marks here, you must have written down something times by the scale factor. So you must show the multiplication and then your answer is 10. So that's if you've done that version. Remember, it's only worth 2 marks. You've done one of the 3 versions there. Part B, same sort of idea. This one looks at the ratio of the small triangle. So small triangle side over big triangle side, small triangle side over big triangle side. If you've written that equation down, you get 1 mark. Multiplying everything by 8, I get this. And working that out, 3 times 8 is 24, over 12 is 2. Similarly, if I go for sides in the small triangle, sides in the big triangle, I get the same thing. So 1 mark if you've done your equation, 1 mark for your answer. And if I'm going for the scale factor, well, small to large was multiplied by 4. So large to small is multiplied by 1/4 or divide by 4. Either of those, but again you must show the multiplication or division to get both those marks. So 1 mark for your multiplication or division, 1 mark for your answer. Question 6, another similar triangles question. These quite common type because people get a little confused at what they're seeing here. But really what you're seeing is one triangle, a small triangle, stuck on top of a large triangle. These 2 sides are parallel, so we know that they are similar triangles because they have a shared angle here. Angle underneath P is the same on both triangles, and then they've got corresponding angles are the same there. So I know I've got similar triangles. So I split it up into 2 triangles. I've got my diagram here. This is triangle PQT, and this is the bigger one underneath PRS. Put on the sides that you know. So you know that PQ is 6, PT is 9, and I know that PR is 6 and 2, which is 8, and PS, I don't know what it is. So I've decided to call it, I can call it PS or I could call it 9 plus X, but let's deal with part A first. So part A says work out the length of QT. So just see it at the top there. So I've done QT over 14, so that small triangle over big triangle is equal to 6 over 8, which is small triangle over big triangle. So if you've written down that equation, 1 mark. If you've multiplied by 14 and solved it to get 10.5, there's your 2nd mark. Now question part B says work out the length of ST, which is just this bit here. So I decided to call that X. So the whole of that side there, PS, is 9 plus this extra bit X. 9 plus X. So I've got 2 versions of this solution. So I just said that this is my version. Let ST is equal to X, that little bit extra. So I know that the length, the whole of that long side PS is 9 plus X. So working out big triangle over small triangle, 9 plus X over 9 is equal to 8 over 6. Multiply both sides by 9. So 8 times by 9 is 72, divided by 6 is 12. I know that 9 plus X is equal to 12. And taking away 9, I get X is equal to 3. So 1 mark for setting up my equation, 1 mark for getting that the long side, all of that long side is 12, and 1 mark for getting it's 3. That extra little bit. Or I could have done it like this. I could have just called that long side PS and worked out what PS was. So PS over 9 is 8 over 6. You can see it's almost identical to this one. PS comes out at 12, and then I have to just do a subtraction. So if that long side is all 12, and I know the short, I know part of it was 9, 12 take away 9 is 3. Now moving on to the slightly more complex problems with 3D shapes. So the important thing here is to remember that we need to think about length scale factors and then area scale factors and volume scale factors as well later on. So if a square is enlarged by a scale factor of 3, that's the lengths that are enlarged by a scale factor of 3. So the area scale factor would be 3 squared. Any side of 3 squared, or you multiplying by 3 squared or multiplying by 9, gets you that 1 mark, that method mark, and then your final answer is 144 for the second mark. Question 8. This is one of the sort of trickiest ones that you're likely to get. This is ones where you can't work out, you've got to do some of the working out first before you can find the length scale factor. So we know that this shape has got a volume of 130 and a surface area of 202, and this shape has got a volume of 638.69, and we need to work out its surface area. So if I want to work out a surface area, I need to multiply one area by a scale factor squared, which means I need to find the length scale factor. So it's a process mark for this one, because you've got to decide, you've decided that you need the process to find the volume scale factor. So if you've worked out that 630, well actually if you've just written down 638.69 divided by 130, that's your process. The big volume divided by the small volume. So 1 mark for that, and the answer to that bit is 4.913. So that's the volume scale factor. Now the volume scale factor is the length scale factor cubed, which means to find the length scale factor I need to cube root that. So there is 1 mark for cube rooting whatever answer you got there. So if you've cube rooted this answer, you get 1 mark. That gives you 1.7 when you cube root it. And finally, I can work out, now I know my length scale factor, I can work out my area scale factor because it's that squared. So the surface area of y is going to be 202 multiplied by whatever I got there squared. So if you've multiplied 202 by this answer squared, you get a mark. If you've got the correct answers all the way through, you will have got 583.78 is your final answer, which is you get an accuracy mark for that. So, question 9. 2 similar solids. We can see that this diameter is 3 times that diameter, so I know if they're similar, then this one, all the lengths are 3 times that length, which means I can work out what the area scale factor is and what the volume scale factor is. So it takes 30 millilitres of paint to paint cylinder A, so it takes 30 millilitres to cover that area. I need to know how many times bigger that area is than that one. So area B was times by 3 squared. So if you've done any multiplication by 3 squared, you get 1 mark. So the amount of paint you're going to need is going to be the paint you needed for area A multiplied by 3 squared, which is 270. If you've written 9 instead of 3 squared, that's absolutely fine. So all of these are all equivalent. But anybody who's marking these will look for the fact that you know you've got to square it, so you've written something squared. Same on this one. This one underneath, we have got the volume of A, we need to work out the volume of B. We know the length scale factor is 3, so the volume scale factor is that length scale factor cubed. So just the fact that you know it's that length scale factor cubed gets you 1 mark. And then you multiplying by the length scale, so 5,658 times by that thing cubed gets you, would have written 27 there if you wanted to, gets you your second mark, and your third mark is for 152,766 cubic centimetres. Now then, on to the last difficult questions here. So, this time we've got a purely algebra one, purely algebraic this one. So, rectangles KLMN and PQRS are similar, which means this one, there is a scale factor that multiplies this to get that. And once I know what that length scale factor is, I can work out the area, which is what I need to prove. So I do it in exactly the same way as I would have done with numbers. It's no different, it's a bit of algebra. So to work out what I multiply this by to get this, I do that divided by that. So x squared minus 2 all divided by 3 lots of x minus 2. If you've written that down, you get 1 mark. Even if you've done nothing else, you still get that 1 mark. Your next mark is for simplifying that. So to go further with this, you need to factorise this using the difference of two squares, x minus 2x plus 2. And so you can see that there is a factor of x minus 2 on the top and the bottom, so which you can cancel. So simplifying it to get down to x plus 2 over 3 gets you 1 mark. Now it is a proof question, so you need to show that. You can't just skip from that to that. You do need to show that you've factorised and cancelled. You can have it in its alternate form if you want. It doesn't matter. So I know that that is the length scale factor. So the area scale factor is going to be this one squared. So I square the top and I square the bottom. So I've got x plus 2 all squared on the top and 9 on the bottom. Now, my final part of my proof. So the area of the big rectangle is equal to the area of the small rectangle times by the area scale factor. So I need to see 9 times whatever you had here squared. So this thing. And then your final mark is for some fully correct algebra that produces the answer that you're trying to get. So you need to show that that's expanded, you need to show that these are cancelled, and that you end up with, once you've expanded and simplified, you end up with x squared plus 4x plus 4. The algebra must work to get that final mark. Question 11 then. We're on to the more difficult of the congruency proofs. More difficult because of the way you're expected to write them down. So these require a certain geometrical language in order to get the marks. So we're told that x is the midpoint of JK and the midpoint of LM. Prove that the true triangles JLX and KMX are congruent. You must show all your working clearly, giving reasons. So this is technically working. All these written statements are you working. So if I'm proving congruency, ultimately I want one of these 3-letter abbreviations at the end as my final reason. It's fairly obvious which one this is going to be, because I've got that side, and the angle in between are the same on each triangle. So I need to state that LX is equal to XM and JX is equal to XK. You need to have written both of those down, and to get the mark there needs to be a reason for that, and the reason can either be, since X is the midpoint of LM, then that's true. Since X is the midpoint of JK, then that's true. Or it could be written on your diagram. If you've written that that length there is 7.1 and that's 7.1, and this length here is 3 and that's 3, then that is enough, but your diagram has got to be annotated to get that if you haven't written this bit. So that's the side lengths, and then I've got my angles. So angle LXJ is equal to angle KXM, and then I must have a reason. Can't just write that, there needs to be a reason why they're equal, and that's because vertically opposite angles are equal. So a statement about the angles and the reason gets you the second mark, and the third mark is your final conclusion. Triangle JLX and triangle KMX are congruent, and that's your reason, SAS. That must be written. If you've just written that, you don't get that final mark. You must write that. Now that question's out of 3 marks, not 2 as it says on the paper. And our final one. I had to get my coloured pens out for this one. I found this one quite difficult to see because there's so many crossing lines. But there's nothing wrong with that. There's nothing wrong with actually drawing on the diagram. You're encouraged to do that as long as you can still see it. And you can take highlighters into an exam to go over this. So the reason I did this was so I could start identifying equal sides. So I've got my purple triangle ABE and my turquoise triangle ADG, and I know that AEFG is a square and ABCD is a square, and they're different size squares because they're on different sides of a right angled triangle. However, I can see that that side there in the turquoise triangle and this side here in the purple triangle are the same length because they're on the same side of a square. Sorry, they're on the same square, I should say. And similarly, in the small square, this turquoise side and this purple side are the same length because they're on the same square. So that needs to be stated. AE equals AG, sides of square AEFG. You don't need the R equal, I don't think. You can just, as long as you say that they're the sides of a square. And that AD equals AB because they're the sides of a square ABCD. So again, statements about a pair of equal sides. And then we need to say something about angles. Well, I've identified that side and that side in each triangle. So if I could do the angle in between, then I'm looking at SAS again. Now, I can see that this angle is 90 degrees. I've drawn this in, by the way. That wasn't on the original diagram, but it's a square, so that's 90 degrees. And that's 90 degrees. And they both share this angle. Now, I've called it theta, but you could call it angle DAE. So, let's state the angle DAG. So, DAG, the obtuse angle, is 90 plus theta. Angle EAB is 90 plus theta, so angle DAG and angle EAB are equal. Now, in order to get that mark, there needs to be you can't just write that line there. It needs to be absolutely clear where it's come from. In other words, how the obtuse angle is composed. Once you've done that, your final conclusion again. So triangle ABE and triangle ADG are congruent, and then you must write that for your final mark, that 3-letter abbreviation SAS, side, angle, side. Okay, so that should be out of 40. What you need to do now is to make sure that you have marked it, done your corrections where you need to, and photograph it to send it to your teacher. The best way to do that is to put 2 pieces of paper side by side like this and take a picture above with your phone. Your teacher will be able to read it. So if you can do that, your teacher will be able to read it and send it in. Okay, thank you for doing this, and we'll see you in September.